And throughout the workshop, if you have any questions, just drop them in the chat or just like speak up if you want to.
All right, I'm going to share my screen. I hope I have permissions to do that. Oh, I think you have to enable it, streaming.
Yeah, now try.
Okay, do this. Okay, can everyone see my screen?
Yep.
Perfect. So just today we're going to talk about some cloud tech areas and also about soft skills, right? That's what the topic is. Make sure you are in the right workshop, just to make sure. This is what I'm from Acton, Massachusetts, like most of the organizers here. And I work in AWS as a technical account manager. What it means is like I work with customers who already like moved into AWS, but I'm working with them to mature and improve and drive the adoption of cloud across the company. So I work directly with customers in the field. I've been with AWS for almost more than 3 years now. So that's about myself. So yeah, I just a few things. I went to school in India for electronics and communication engineering, and then I studied about organizational behavior and psychology in Harvard. I worked in Dell EMC, used to be called EMC, now it's called Bell EMC, and prior to AWS, I worked at Microsoft. My pastime, I play tennis for recreation. I'm also a huge Celtics basketball fan. I watch a lot of NBA games in my spare time. That's about me. So today, what are we going to talk about, right? We're going to talk about cloud computing. I mean, like from the ground up, like what's an application, what's infrastructure, what's the data center, and how does this become cloud, and something about AWS and how can get free education from AWS. Some of the things that I speak to a lot of young teens, like this is interesting segue, like how do you get into tech, right? Like what is the different career paths, right? What are the skills you need? So I'm going to talk a little more about that in the middle of the presentation, and also going to talk about soft skills and why it is so important to be successful in your careers. During this thing, I know it's a small group. I don't mind you interrupting and asking questions. Just to keep in mind, there is no dumb questions. We are all here to learn together. So you will not be judged because you're asking a question. We encourage you asking more questions so that it is interactive and helpful. So just full disclosure, there's nothing called a wrong question or incorrect question. Okay. So we'll talk about 45 minutes, but I put in the slide. I need to change this. You can interrupt me anytime. As we mentioned, video is already on. If you have using mobile phones, if you can switch off, that'll be appreciated. All right, what is cloud computing and how does the AWS fit in this whole thing, right? So maybe how many of you use Netflix, Instagram, Snapchat, Fortnite? I can't see everyone. I'm kind of sharing my screen. Srini, if you can tell me how many of them, somebody, you can put in the chat if you use them or you raise your hand. Use them. Srini, can you tell me if anyone raising the hand or anyone using Snapchat?
Yeah, one person raised their hand.
Okay. Nobody uses anything else. Okay. All right. So let's take, if you use, I don't know, let's take Snapchat or Instagram for a reason, for a minute. Let's say if you use one of them, the reason I asked the question is all these applications run in cloud, in fact, in AWS. So how does this application work, right? Let's just put the cloud in the back burner for some time. So you're using your mobile phone, you have a Wi-Fi connection or a wireless connection with the data, or you may have in the house and use the physical internet. And then when you say Snapchat, it goes to the wireless internet, or it is wired or wireless. It goes to a data center where we have servers and storage and racks and stuff. And then these applications are installed or deployed on this data center. That's the way it was there, let's say 2008, before 2008. Even today, like only 20% of the companies are moved into cloud. So 80% of all the applications that you use are using are running, or all in the all we call it in the physical data center. So that's the way the application works. This mobile device could be a phone, computer, laptop, could be anything, right? The same phenomenon. So when you talk about this data center, these are like physical things. You have to pay for it. You have to power. You have to pay for electricity, cooling, everything. These are managed either by the companies themselves, or they kind of outsource that and they kind of rent those spaces. So that is what a data center means. So this data center is replaced by AWS. That's all cloud is, right? Rather than you building and maintaining it, AWS maintains them, and you just buy a piece of that or buy a service and deploy these applications. Same thing, right? Still, you go to a wireless connection, internet, and then you go into the cloud, right? And then, in the cloud era, all these applications are in fact hosted in a region within the cloud. So we call it public cloud, but it's pretty much, I would say, the basics of cloud. This is where the applications work, right? So let's talk about how the consumer devices, right? We talked about your laptops, phones. Pretty much what they do is they pull the information from the application which we talked about and displays it. Or you enter something in your chat to your friend, like Instagram, or you post something, it captures that and pushes it to the application via, like, into the, it just captures the information and posts it somewhere into the server, maybe the cloud, and then sometimes you get results back, so on and so forth. So this is pretty much your consumer devices, right? Like your laptops and stuff. So what is a PC, right? When a PC can be synonymously used as a laptop, right? But these are the applications you as a user interact with that. So that's where it is. However, in the servers or this massive infrastructure, it's connected through internet with the users, right? So it connects the servers via internet to the users, and this service, as we talked about, can host any of this application. So we need to understand the distinguish between the physical laptop or a server. Before we go further, does anyone has any questions so far? Okay, all right. So now what is this infrastructure? We talked about server, right? What is it used for? It hosts the information, or it stores some data, and then it pushes the information to a consumer device, right? That's a server, so we call it servers. And then in the components of infrastructure, we have storage, right? Your hard disk. These are massive hard disks. These are complicated infrastructure. And also you need network that communicates between the different servers and the users and the data center, that we need that. And compute power, which is what the CPU and RAM, right? Processes the data, runs the code, and all those things you need. The combination of this infrastructure is what we call, a simple terms, infrastructure, right? So when we look at the cloud, this infrastructure is pre-built for you and then charged by a basic unit, by the minute or an hour or whatever. So this is what the fundamentals of what we call the infrastructure. What is the data center, right? So a data center is basically all the server infrastructure is located in one place. So for example, if you look at when someone says I have a data center, this is what it looks like. Even the cloud data center looks like that. There is a cooling system. These are the big machines, which is basically represented here. They're all hosted in cages, or like we call it like a cupboards. Then we have racks and racks of these service. So this pretty much all these blocks you see all looks like this, right? This may be a massive, mostly it looks like this, but it would be a massive football field. If you're living in Massachusetts, or you're in this area, Waltham, that is, and Cambridge, Massachusetts, you have quite a few data centers, right? So it has dedicated power. It looks like a massive warehouse, and it could host many websites, applications, and all the infrastructure is in one place, right? Pre-cloud, let's say 2008, you have to buy this like components, like Lego boxes, right? Use Legos, so you buy servers from EMC, the IBM. You buy these, I don't know, machines from IBM, and then you may use even Dell. Dell also used to make some network devices, and you cable them. You have to rack them. You need to do a lot of, plumbing and connection, and you rack them in these cupboards, right? You buy a network from Cisco or Brooked. All those things were all assembled, right? And this required a lot of work, and it is expensive too, right? Let's say you are let's say you are a drug discovery company like a Pfizer or Moderna, which make COVID vaccines. IT. The data center building is not the core competency. Their core competency is discovering drugs. For them, this was very inconvenient and expensive. So let's look at this analogy, right? So I don't know, the peak of the pandemic, a lot of people started cooking. I don't know if anyone of you here know how to make a pizza? I don't know. I'm just asking the question, but anyone raising the hand? Anyone know how to make a pizza at home? Srini, is anyone raising the hand?
No.
No.
Although, actually, no, one person has. Dave says he knows how to make a pizza.
Okay. So
And
Dave,
Zainab too.
I'm sorry?
Like so there's some people like physically raising their hands in their videos.
Oh, fantastic. So can anyone say which is the easiest thing? What pros and cons about making pizza at home or buying it from a store? You can.
Oh yeah, can I just say, okay, so I mean, making a pizza at home, some advantages of that are that, sometimes it's cheaper just to buy the ingredients and, do it yourself. You can also like, if the pizza shop does not have any like options, you can also, add your own toppings. Yeah, and then like for a pizza shop, the kind of advantages of that is that it takes a lot less time for you to kind of like, make a pizza and then bake it, because you can just order it and then they, serve it to you and then you can eat it.
Okay, awesome. I don't know your name. Who's this? May I address you? So Dave?
Yeah.
Dave. Okay, thanks, Dave. So Dave, let's say you are hosting a party at home. Would you rather build a pizza at home or you buy at a pizza shop?
Yeah, I mean, it's probably easier just to buy at like a pizza shop because it's like because it's like, it's a lot of pizzas and that's going to take like a lot of time if you don't have like, for example, like a small oven or just, yeah, it'll take a lot less time.
Perfect, thank you. Have you heard the term scaling? Scale. Have anyone, do you know the meaning of the term scale? If you don't know,
Yeah.
that's fine.
Yeah,
sorry, you know that? Oh, okay, yeah,
yeah, sorry. Yeah, I
go
do.
ahead.
So
So
it's like
please.
scaling means that, so, back with the pizza analogy, right? So if you make a pizza at home, you can feed like, one or two people, if it's like a small pizza. But then if you have to feed like 10 people, then it's a lot harder and it takes much, much more time. Whereas if you buy at a pizza shop, then, even if you're serving like one person or 10 people or like 100, it's like, it takes less time to serve more people basically. And then sort of.
Perfect.
Yeah.
You made my job easier, Dave. Thank you so much for explaining that beautifully. So if you look at that, building your own data center is making your own pizza. Yes, you can add your own toppings, customize it as much as you want, but you can't scale. If I'm hosting a large party, it's difficult. As Dave beautifully explained, you can't scale. Let's say you want to build more servers, more applications, you can't scale. And I want to, public cloud companies like AWS, we serve the whole world, as you'll see, in a few slides, but then we can't scale. So think about private cloud or data center is like making your own pizza, and buying pizza at pizza shop is what cloud is, right? So thank you, Dave, for helping me out. Appreciate it. And I like your analogy and explanation, really helpful. Thank you. So what is cloud, right? So another analogy I can look at, like single family home. I don't know, people are living in a home, the single family home is a data center. Like for example, you have your own like a water connection, cable, internet, in fact, your own sewer system, everything is self-contained, right? It's customized. But if you live in an apartment or like a flat in some Asian countries, you call it, it's all shared, right? You own a piece of that apartment. You share things, right? Even though you pay for one unit, but you're not responsible for the roof and cable and water sewer. It's all shared, right? You own a piece of it. It's like a shared location or shared hosting, right? So that is what public cloud is. You're owning a piece of it. You have your own tenant or your own location. That's another way to look at public cloud. So with the cloud, the application infrastructure is available for many users over the internet, right? So we have clusters of data centers all over the world, as you can see, not just the US, you have in Europe, you have in India, Middle East, even like South Africa, Australia, South Asian countries, even in South America. So we have all these tenants or apartments built in, we call it regions, all over the world, so that you can consume and build applications anywhere in the world and still have the same kind of user experience, right? So that was not possible, right? No company has built this massive infrastructure all over the world. And the most important thing is, you pay by the minute, like just your phone bill or your electricity bill. You have meter billing. So basically, at the end of the day, cloud is a cluster of data centers around the globe, right? Each region or each dot in the picture is basically a data center managed and owned by AWS. That's all it is. Yeah, this is a different picture within, like, for example, if you look at the east, we have one in Ohio and Northern Virginia. We call it like if you're using cloud, if anyone uses, it's called US East 1, East 2. That means that let's say you're on the East Coast, you probably will use either Ohio or Northern Virginia, right? And we also have a GovCloud, which means like the CIA, the NSA, the Pentagon, all the government regulated, they have their own cloud. So the rest of the cloud, we call it like commercial cloud, but this is like government cloud, which is highly regulated, their own things, and we have that around the world. And also some countries like the European countries, they don't want the data to reside as, we call it data residency, meaning that the data cannot move outside of EU or the European Union. Then for that, we also have a data center in the Stockholm region. Same thing with Bahrain and Hong Kong, because they have highly data residency requirements, meaning that let's say you have an application, the data cannot be stored in a data center in Ohio, for example. It has to be in Hong Kong. So that's pretty much, like some regulatory requirements we have, GovCloud and those kind of things. Any questions, anyone, before we go further? Okay. All right. So in net, AWS is, in my opinion, it's a services, list of services, which is basically Lego box, right? You can use, you want to build analytics application, you can use analytics services. If you want to use AR and virtual reality, you can use those services. You want to use game technology, you can do them. You have media services, which is heavily used by companies like Netflix, Prime, you name it. Like, for example, Disney Plus, Hulu. You can build services using media services and build an online streaming platform, for example. You can build mobile applications. You can do robotics, right? Machine learning, Internet of Things. The products are there. You're supposed to just connect them, as like the pizza example, bring them together and scale, right? Some of the things I just wanted to call out, right? Even the very mature users I work with have some myths about public cloud, right? They say, oh, it's a cloud, I don't need to take backup. Of course, you need to take backup. The fundamental of infrastructure operations doesn't change because it's cloud. We don't back up your data, you have to back up. We only provide the infrastructure and a tenant to you. You own the data, you back it up, stuff like that, right? And then I don't need to plan for disaster recovery. So I have to explain this term disaster recovery. For example, let's say your application is in, let's go to this picture, in Northern Virginia, right? And then let's say any cloud company can have outage because it's still physics, right? We can have a problem. So if users are hitting this and this is down, your application may outage. So we fail over to Ohio, which means application fail overs to Ohio. So there's no disruption. That is, we call disaster recovery. When some disaster happens, let's say there's an earthquake in Northern Virginia, just for the sake of discussion, or there is a massive flooding. AWS cannot say, oh, I can't operate. So we ask the customers to have a disaster recovery plan so that they can fail over the application to Ohio. So this is still a customer responsibility. We call it shared responsibility. The customers has to have that. Just because it's cloud, not everything is owned and managed by the cloud provider. You still have to iterate your applications post-cloud deployment. You still have to mature them, make them better over a period of time. It's not like once I deploy to the cloud, I don't need to do anything. The fundamental of software engineering doesn't change just because you're in the cloud. Okay, so some myths you might come across when you start using cloud, but just wanted to share that with you. So how does this cloud work? I'm not going to do a live demo, but basically, if you use Amazon.com or any online website to buy stuff, that's the same experience we have. Let's say I want to build a VM virtual machine. I want to select it comes with the various flavors, various versions of Linux, or you want to buy Red Hat, this kind of, like a product in any, I would say, enterprise grade thing you can put Red Hat on. You can just buy SUSE Linux, right? These are all the flavors. We also have the own Linux. You select what is the processor, ARM processor, or Intel. You select them. And then you say, hey, what type of size I need? How many virtual CPUs, memory, storage, network performance? You select them. And when you just confirm the instance type and like you also provide some security groups and networking, but when you click launch, you're building a server. It takes minutes to build a server, right? Instead of some cases in on-premise take months or weeks. So that's as simple as that, right? Like you can build infrastructure very easily without going through a lot of hoops, right? But still, you still have to install application for making it meaningful, but that's the kind of experience you have. So how can you learn about AWS? Obviously, I'm not teaching AWS. It's like there's few more AWS sessions, but if you want to learn AWS, is a free website that you can register, and it's completely free. You can build a cloud skills on your own pace, own time, and you can self-learn. You don't need to pay anything. You can do the convenience of your home. It's open to any individual, irrespective of experience education. It's a simple, barrier-free access, designed for beginners, and also has connections to employment, right? So I will highly encourage that you go through that. I mean, as I said, it's just not for, it's a learning path for everyone. And this is another way to self-learn and, drive your, design your own path of learning. All right, before I go, any other questions on cloud? You can, unmute yourself and ask the question. That's fine. If you don't want to talk, you can type as well, and Srini can translate that to me.
No questions so far.
Okay, fair enough. So I hope you got some basic understanding of what cloud is. You'll be surprised. The reason I put this, guys, it is for like teenagers and stuff. You'll be surprised how many big corporations, directors, and VPs don't understand some of these principles. I made a personal mission of making it as simple as possible. Hopefully this is useful, right? At least you know what cloud is and what it's not, and it might help you in your journey of learning tech. I just hope so. All right. So let's say you decide I want to go into tech. Like, what are the careers? There's a lot of myths and misinformation out there, so I'm just going to lay out there. So what really happens when you get out of college, right? I don't know. I'm not saying that. I'm expecting many of you college students, but let's say even if I'm sure the high schoolers, that's junior, seniors, you may be going to college or planning to go to college, but just some kind of reality of what really happens, right? So you have high expectations. You think the life is going to go in a straight line from south to north, but this is like just like a tree grows, right? It's a plant and then it goes to big, and it becomes a tree. Actually, doesn't happen in real life, right? The tree has many iterations. Sometimes it has to go through down, like it has to go all these spirals and flowers. Sometimes it's good things happening. And that's what in reality. Another way to look at it, you work really hard, you feel insecure, and then you fail a lot, you get a lot of helps, life happens, and then you reach to the thing. It is not this, but this is the reality. This is what happened to me, and 90% of people who in the workforce are older than you. Every adult goes through this. So if this happens to you, at least you'll never have life like this, right? So just be prepared for that. That's what the truth and reality is. So I always feel like people, I'm not good at coding, so I can't get into tech. I need to be a nerd to be in tech. I need to be great in programming or coding. I'm not good in math. Coding is boring. right? So these are the things I heard kids tell, and I feel like this is all not true. In some ways, one of the things I learned from my own experience is like you need to have some conceptual understanding of how computers work. It's still a valuable skill, right? Even though you may not be great in programming, you can still use that knowledge to solve so many problems in the tech industry. If you have a strong analytical ability to analyze things, that's still valuable. Teamwork, like the Hack3, I'm sure you're working with so many team members in Hack3. So you learn the teamwork skills, which is very, very critical, right? Your communication skills, how do you communicate verbally, non-verbally, writing, reading skills is very, very important. Soft skills, which you're going to talk about. And most importantly, hard work, right? And the ability to solve problems, right? Problem solving skills. STEM major is preferred, but I can tell you in my company, there's a lot of non-STEM majors still doing great in AWS. So that's a fact. So this is what the myth and the reality is. So there's two types of jobs you can, let's say you do a BS in information sciences or computer sciences. So you could work on these companies, which we call them consumers of cloud or consumers of tech. For example, Nike builds shoes. They use technology to sell more shoes, right? Target, they use technology to sell groceries, Staples, Walmart, you name it, TJX, all these companies use technology. They're not building technology, they're not building products, unlike Apple or Facebook. Those are different. So these are consumers of technology. They use technology to make the business better, right? So it's study of computers and people and how computers and people interact. If you go into this field or to these majors, you kind of create systems and findings. Let's say you create for storing data or information exchange between people, or use the information to sell some products. That's what it is. So you get jobs in this industry, right? We call it like the consumers of technology. They buy technology to improve the business, like Walmart.com, right? Or Staples.com runs on a data center or cloud, right? So you will be having jobs there. The another set of things is we are producers of technology. This requires a little bit more depth of education, I would say, computer science or computer engineering. It's more about study of programming languages, deep technical skills, and a new perspective on problem solving. You take a complex problem, break apart, and execute them effectively, right? So Bose is, we all know Bose is, they manufacture headsets and music and audio equipment. They require engineering background because they're building something. Same thing with AWS. Not to say that non-computer engineers don't work there, but let's say you're building data centers, you really need that computer engineering background because you don't need to know the hardware and software part of it, right? So Apple, same thing. We build headsets, phones, TV, like Apple TV. So streaming, all those businesses, they require deeper computer science knowledge. Same thing with Facebook. So these are the two types of industries you can branch out when you study something related to computer science. But also these companies have product marketing and sales teams. And even if you don't have a major in these things, you can still get a high-paying job working in, we call it like product marketing and stuff like that. So it is possible. In fact, just to let you know, the CEO of Microsoft, Satya Nadella, was a product marketing person. He was not in the engineering, but the last job he had before the CEO of Microsoft, he was a product marketing guy. So you don't need to take the traditional path to become a CEO, even, for example. So let's talk about you chose to say, oh, I'm not going to do computer science, but there is still an option. You can do any of these majors, industrial, mechanical, electrical, or even physics, biology. You can still minor in computer science, even chemistry, mathematics. In fact, it'd be valuable because you use computer to solve a complex physics problem or biology problem, then computer science becomes a tool, right? So you can still major, minor. There's another option to get into the field. Let's say you're working on let's say Moderna, right? You're doing biology, but they want someone who understands biology also knows how to automate some complex procedures through computer science or software. So you become very valuable to a company like Moderna. That's why this combination, sorry. this combination would work great. The next hybrid model is like, I'm doing arts. Of course, you can minor in computer science. Any of these social sciences, humanities, creative arts, still you can have a path in computer science. So it may not be the traditional path. It's still there is a path to make it to the field, right? So let's talk about money, of course, right? This is last year's data, 2021, but this is the median salary for a US full-time worker, right? I don't know about other countries, but this is the 51K is or $984 per week is the average salary. So this is just based on US data, not any other country. But if you look at the range, you can earn up to 122K, or even like the least or the most lowest band of computer science salary is like 54K. Just getting into this field, even if you look at money, you still double the national average, right, in terms of median pay. I mean, these are different various roles, but we're not going to go with that. But I'm just saying that there's a range in like anything else, but this is what you can achieve. Any questions on the computer science careers? Okay. Anyone raising, waving, typing? All right. Okay, I'm going to continue. All right. So let's talk about soft skills. I can tell you this, in my own career, I've been in the industry for 30 years. I can tell you this is a fact. The most important skill for you to grow, let's say your technical skills and your academic skills is important, but I would say that this only contributes a small portion of how well you will succeed in your career going forward, right, after college. And I'll tell you why. So there is a person called Dr. Daniel Goleman. He's a researcher who just researched on emotional intelligence. And he just did a research on, like, so let's say this is the third, like, you to succeed in a job, let's say you're individual contributors, that you work for someone, you only need 33% of tech skills or like academic skills, and you need 66% of emotional intelligence skills to succeed. It's a huge disparity. 66%. Most people, I don't know, normally I would assume this is the other way around, but this is what the data is. But you want to become a CEO, want to grow up, it's even more important. Your technical skills becomes less valuable, and your emotional intelligence skills is even more valuable. So that's the reality. So I'm not saying, for example, just because knowing AWS, let's say you apply a job and get it, that's still going to be valued at 33%. The other skills is going to be making you more skillful. And we'll figure out how. Your attitude, not your aptitude. Attitude is your skill, will determine your altitude, the growth. Your attitude is the most important thing. And let's unpack this. So in terms of skills, like your subject matter expertise, the school you went to, your math and statistics knowledge, data and technical skills, any other skills is called hard skills. That can be trained, it can be learned. Like going to school, college, taking an online course, possible. But soft skills like problem solving, storytelling, collaboration, curiosity, communication, creativity, those things cannot be taught in school. You have to learn, or you have the skill, right? So that is the difference in hard skill and soft skill. Srini, I want to show a video. I think there's a separate setting to do a video.
I think you should just be able to click on the YouTube link and it'll play it.
I don't know about audio. Sometimes I
You
thought
might want to stop the share and start it again with like optimize for video clip, that checkbox in the bottom left corner when you're sharing.
Yeah, let me see.
Yeah, when you share, there should be like an option to click share with sound or something.
Okay, hold on. Okay, hold on. Share sound, optimize for video clip.
Yeah. Just check off both of those.
Okay. All right. You guys tell me we can hear.
When it comes to work skills, they can be
Can
broken
hear?
down into two
Yeah, we
types,
can hear you.
Okay.
hard
Yep.
skills and soft skills. They're pretty different from one another, but both are necessary to be successful on the job. Let's take a look at the differences between the two. Hard skills are concrete skills that are specific to your job and are required for you to actually do your work. For example, if you're a chef, cooking would be a hard skill. Or if you're a computer programmer, coding would be an example. Soft skills, on the other hand, are interpersonal or people skills that can be used in every job. These include communication, teamwork, and adaptability. Hard skills are generally learned through school, training, or previous work experience. They're more objective, meaning that once you've learned the information or task, you would then possess that skill. Soft skills are more difficult to develop. You'll need to practice them over time in the real world with others. They come naturally to some people, while others may not have such an easy time with them. Hard skills are easy to measure. Employers can get a good idea of your hard skills by looking at your education, previous experience, and certifications. Soft skills are harder to evaluate. They can't really be communicated well through your cover letter or resume. Instead, employers usually have to wait until an interview or your first few weeks on the job to get a good idea of your soft skills. Despite their differences, you'll need both hard and soft skills if you want to become more hireable or be successful in your current job.
Goodwill Community Foundation, creating.
All right. Hope people got some idea about what I was talking about. All right, let me. Sorry. Hold on. I'm gonna share. All right. Can you still see my presentation?
Yep.
Okay, perfect. Oh my God. Sorry. Always something. Okay. All right. Maybe it looks okay. Perfect. So we just talked about that. So this is another quote. So 80%, 85% of your financial success is due to skills in human engineering, which is basically soft skills, your personality, your ability to communicate, negotiate, lead, and only 15% is due to technical knowledge, which is again a research based on Carnegie Institute of Technology, which is kind of goes back to the earlier research on which skill is important. And this is a, I don't know if you use Netflix, the CEO's quote, I do not tolerate brilliant jerks. The cost to teamwork is too high. So Netflix has a very, very difficult hiring process, but just because you're smart, if you're not a good team player, actually you could get fired from Netflix. So that is what it is. All right, grit. This is another skill, right? Your talent, what it really sells is, if you read this book, I highly recommend it. I had a privilege to meet that author many years ago. What she explains is your talent or your coding skills is hardly a guarantee of success. I'm not saying don't do coding and you don't do anything and it'll be fine, no. But I'm just saying that's not the one that determines your success. Your passion and perseverance is going to be it's important hallmark of high achievers in every domain, irrespective of the field you choose to do work at. But the grit is and talent. Grit is not talent is not a guarantee of success. So being gritty is extremely important. All right, so I don't know if you have questions, but I'm going to just summarize. I personally believe anyone can code. I've always started a story. I forgot to mention that. When I started this career, I didn't know how to use a mouse. In my college in India, we didn't have a lot of facilities in computers. Actually, I learned used to use the mouse in my first job. Here I am, right? 30 years later. So if I can do it, you can do it. So anybody can code. I don't believe that coding is like for nerds. So please, if you have that mindset, please just try it today. Subscribe to AWS Educate. and like I still learn. I still have to study every day. Never a day that I never feel like I know everything. I'm still learning, even though I'm in the cloud business for 6 years. So I have a mindset of lifelong learning. It comes to soft skills, it's all your mindset, right? A positive mindset to learn, your attitude and effort, not your brain power is going to help. So remember that. Choose a career that suits you, right? Everyone has their own superpower and strength. Even today, you can, after this presentation, you feel like cloud and tech is not for you. That's fine. That doesn't mean that you aren't successful, right? You should choose a path that suits you, not because your friend is saying or a friend is going to that field. So hopefully you choose a path that this presentation was helpful to choose a path that fits you, right? I will not be disappointed if you feel like, okay, I'm not going to do tech. This is not for me. That is totally fine. I think that's the right thing for you, and you should pursue that, whatever it may be. So with that, I conclude my session. But I'm open for questions. I'm going to stop sharing. I can stay here. We have 15 minutes. If people want to ask questions, I'm happy to answer anything about AWS, tech, or anything in between.
Question from Matthew. What is AWS Educate?
Yeah. So as I said, this is like a training or certification path built by AWS to encourage people to get trained on a self-paced way, right? You don't need to pay for it. It meets you at the right level. For example, in some certifications, you need to have a degree or experience. We don't assume that anyone can learn. You can start. I don't know anything about computers. Still, you have a path. We'll meet you where you are, and that's where you can get free educations. Think about a learning website. Like if you use Udemy or like any other thing, or YouTube videos to learn, think about it as an official thing that is AWS is providing it for you for free. And it can also, as I mentioned earlier, it can also help you in some getting into gainful employment. Yeah, it's a great question. Yes, it is very, very hard to get as a high school student, right? The first and foremost, I'll just read the question. How do you recommend we get experience as high school students in the field, as it can be hard to find internships or jobs at this level? That's a valid question. So normally companies would not employ high schoolers unless you want a big channel, like some extraordinary things, or you publish some paper, or you have very, very rarely, I would say, you will get internships. So this is what I would recommend, right? So this is a real story. I mean, Jonathan and we all live in the community. I'm a volunteer at AB School. I live in Acton, the same school system as Jonathan goes through. So one of the things I saw like last year, there was a scholarship award for seniors, is like there was a local startup company, which is not a name brand, but they went to the computer science department of the school and recruited kids to do a programming job. It was a internship, not to call it internship. Maybe, I don't know whether they paid them, but they learned skills. So don't look at Google, Amazon to get that. This company, nobody knows about this company. They're just a startup, like started by a few people in the community. And they use your high school computer science department or mathematics department to ask for those opportunities, because that still exists. That's number one. Number two is be curious. Write about some problems you have, about opinion about that. Publish a research paper in computer science. That is for free. You don't need to ask permission to anyone. You can just go and publish it and ask professors some professor in whichever college near you or anywhere in the world. Hey, I wrote this paper. This is my thesis. This is what it is. I found out. What do you think about it? Right? They might give you research, but at least you're a published researcher at this time. Then that will open up new opportunities. That's the one way to do it. I've seen kids going to great colleges just by writing research papers, right? Because that's phenomenal. And find work for free, right? So even internships, not every internship is going to pay. So let's say you have a town and they are trying to automate something and everything is paper, like they get, let's say, I don't know, the town is like, let's say there's in my town, the people give parking stickers to park in the town. That is heavily manual, right? You have to fill a form. You build an application for free. or they fund you, or whatever. Write an application even in Google Forms and show them how we can do without paper. There you get the experience, right? So and even startups they don't have money, they will take anyone for free. I mean, you have to have some skills, but approach startups. Don't go to I actually, in my opinion, you should not do internship in Google, Microsoft, or something as a fresher, because you might go to Google and you may be working on Excel spreadsheets. Who cares? I did an Excel spreadsheet project in Google. So what? Nobody cares. So I would say those are the 3 ways you should approach internships. Now, don't go the traditional way of I'm going to apply to AWS and someone will get back to me. No, it's not going to work. Hopefully that answers your question. What motivates you to go to work every day? Interesting question. So for me, at least, I don't have the same old job every day. Every day is a new problem. I work with customers. The customers comes with different problems or challenges every day. So it's interesting. I'm not doing the same monotonous job. Like even a software program, I'm not doing software programming right now, but I'm not a software programmer where take up the same code, enhance it. I'm not doing the same thing. That's not my job. So I find new problems, new challenges with my customers. So it's interesting every day. I don't know what next Monday will throw at me. Next thing is, in Amazon, we have this culture of you do your day job and you're always encouraged to spend 20% of 50% of time to new projects. So I can work on any project I want to. For example, I work on a tech company. Right now, I'm working on a project where I teach the entire Amazon community, not just AWS, about emotional intelligence. I'm just personally passionate about it, even though I talk, because yes, I'm a techie, but I got a degree at organizational behavior, because what I found personally is if a specific code doesn't work, I can Google it in Stack Overflow, but I don't like Srini. I have a problem. I can't Google how to solve problem with Srini. Srini is getting sad, like, oh, I don't. I love Srini. So I can't Google it and say, how do I solve my conflict with Srini? So I decided to go to school for it. But so that's what I think in Amazon as a big company, we have this own challenges, people, personality, and all those things. And we are trying to educate, not because of COVID, the stress levels, what we do is very high. And we are trying like a program where we teach Amazon how to be emotionally intelligent. Is it related to tech? No. Is it a project I like? Yes, I'm working on other projects that's technology related too, but this company gives me that opportunity to work on things that I like apart from my day job, which motivates me to go to work. It's not just the same job. I can pick anything as long as it helps the company. That part actually motivates me to work in AWS/Amazon. So the other question, what are the specific opportunities to seek out in extracurricular activities? Yeah, so as I said, the same question which was asked, I would do the same thing to you, Mahin. Like the same thing applies, right? Seek out opportunities. Don't limit yourself with internships or something, right? Reach out to people. You find, let's say, I don't know, you buy something in the grocery. So I always get annoyed when I go to the doctor's office, right? They always ask you this big form. You to fill it every time you go. You have to fill this form. Why can't you go and Mahin just automate that? That is a project. That's good looks on your resume. You don't need to pay anyone, and you go and I don't know. I'm assuming you're a high schooler. It looks very good on your college app at a minimum, right? So don't go and solve. You don't need to solve. Just let you know, right? People think about AML. Most of the problems in AWS is not AML. No, we're not going and solving AML every day. Only few companies do AML. Okay, so you don't need to be AML. Don't worry about these buzzwords. In my opinion, technology is about problem solving. If you can make my doctor's life experience, every time I have to fill the same form and I go to a doctor's office about my personal information, why I have to fill that? Waste of my 15 minutes of my time. If you can solve it, that is your opportunity. The next thing is, yes, you might have limited experience knowledge, but doesn't mean that, right? You pick it could be, don't just go for the buzzwords, right? Pick something that interests you within the field of computer science. Be curious. Why is done this way? Why can't, just like ask a question of why do you need to fill the form of what in the doctor's office every time I go to a new clinic? You just think out some problem and solve it with software and write a paper. It doesn't need to be complex, jazzy, I don't know, IoT, game design. No, it does need not be. It could be anything. So you pick the thing and you don't need to compare yourself with others, right? Just you feel like you can still do a research based on that. Hopefully that answers your question. Thanks. These are great questions. I hope it is not just useful for the people who are asking. I hope everyone is getting that benefit.
We have a question from Maheen from earlier on. What are some of the highlights of your experience of learning computer science at university?
Yeah, to be honest, I only studied the hardware part of it. Whatever I know about software is learning from experience, self-learning through experience, I would say. It was, sometimes it's very hard. I would always admit there was failures in my early career because I didn't learn proper programming or coding or structure, learn of way of computer science way back in India. So with that said, the most important thing I learned was to put the effort, right? It's always, when you write programming, don't write the code without a debug statement. That's something I learned the hard way. Just don't, it never will work. If a program works first time, that something is wrong. So you always have to put the debug statement and always assume that's not going to work, and patience and perseverance, right? So that's something I learned like at outside school. So I think being ready to be, I would say, continuous learning, because even though I'm 48, I still have to learn something. But if you feel like if you want to be in a field, there is constant learning in this. There's no way around it. You have to be constantly equip yourself. As I said, cloud came in 2008. I didn't know anything about cloud. Everything I learned through, I was curious. Okay, what is this cloud thing? So things will change. And I think the one thing I learned is like beyond your computer, whatever you learn in university or school is fundamentals. But I think beyond that, you have to really be, we call it in AWS, learn and be curious all the time. That's what the lesson is.
So I know, so this is actually a personal question for me. There are like different fields that you can go into in college, like for example, like information systems or like computer science itself. Is there like, do you know any difference between those two?
Yeah, as I told you earlier, right? So for example, I could be a business analyst just doing like a business analyst role is, for example, you work with programmers and the end users. For that, you need a translator that can know, that can understand, talk to a programmer, not syntactically, and a user who's going to use the system. We call them business analyst, or sometimes the higher level is called product manager, right? Say, for that, information sciences degree is good enough because you're not coding. You are taking the user requirements and translating in a way that a programmer can code. Information sciences degree is good enough, right? That can, if you do an MBA, you can very much go and become a product manager who pretty much goes out and tries to build out the next product or get requirements and keep on making a product. In AWS, we have, let's say EC2. EC2 is a service. There's a product manager who just enhances the EC2 by talking to customers and what the challenges are, how can he make it better. You don't need to code at that level, right? So that information science degree is there. But let's to the other question, other part, if you really wanted to code and that's what the path you wanted to be, yeah, like a developer, software development manager, director, or you want to go in that path, of course, computer science or engineering or computer science degree is important. As we talked about earlier, there is another variation of computer engineering, which is a combination of hardware and software. Let's say I'm building a data center and complex data centers. You may not be coding, but you need to know a lot of infrastructure. A computer science engineering degree may be more appropriate because you learn less of programming, more of architecture, especially hardware architecture, like chip design and all those stuff. So, all right, thanks for the question, Jonathan. Before joining Amazon, I would say I would never say an expert. I was expert and maybe I would say I was doing more of that time Java and Visual Basic. I would say I would be expert on those languages, but I will never call me expert because my path was different. But I don't think you need to be an expert. You need to be good on few languages. I would say today is Python. But yeah, I was pretty much doing a lot of Visual Basic when I started my career, but I evolved since then. But yeah, you need to know one language, but also if you know one thing, especially preferably a compiled language, it's easy to learn other things. You can build up on that.
All right. So it is 4 o'clock. So I think that wraps it up. Thank you, Suresh. That was a very informational workshop, and all of the participants were really engaged. So really like to see that. Jonathan, you want to add anything?
No, Suresh, thank you so much for your time. It was great. And to all the participants who asked questions, thank you so much.
Yeah. Hey, thanks everyone for listening and make it engaging. I really love asking questions. Otherwise,